In this first video for Graphs Grade 8, we're going to have a look at the terminology you need for graphs. Graphs are a visual representation of information that make it easier for people to understand the data that is being shown. A graph can also make it easier to identify a pattern or a trend in the data. To be able to interpret a graph, there is terminology that you need to know. A graph is the representation of the relationship between two variables. On the horizontal axis, we always place the independent variable. This is the variable that is not affected by the changes in the other variable. In our example, the independent variable is time in years, and that will of course pass regardless of the wind power capacity. The dependent variable always goes on the vertical axis, and this variable is influenced by the change in our independent variable. In our example, this is the wind power capacity that increases as the years go by. Sometimes the relationship between the two variables form a pattern, and we are going to focus specifically on those forming a linear pattern. This means that all the data values can be connected with one straight line. Graphs that do not form a straight line can be classified in different ways. For now, we are simply going to say whether a graph is linear or non-linear. If a graph is linear, you need to be able to further say whether it is increasing or decreasing. As you move from left to right, an increasing graph moves upwards, where when you move from left to right, a decreasing graph moves down. And when a linear graph is not increasing or decreasing, we say that it is constant. When drawing graphs, we distinguish between two types of data: discrete data and continuous data. Discrete data is data that is counted. Therefore, it will only be integers. Continuous data is data that is measured. When the graph of discrete data is drawn, the points are not connected with a line. On such a graph, a reading can only be taken at distinct points. For example, we can say that the maximum point is at 7 and that maximum value is 12. Examples of discrete data is the number of people, or number of books, or number of goals scored. Next, if we have a look at continuous data, which is measured, you will have to connect all the points. This means that here you can read any value from the graph. For example, we can choose to read between two plotted points and say that at 6.5, the dependent variable value is about 11.5. Examples of continuous data is the temperature measured daily or the growth of a baby. From a graph, you can read the maximum point and the minimum point. Here we have two examples, and in both of them we have a maximum point. For the soccer ball, the maximum height is at 3 meters, and this happens after 2.5 seconds. So at 2.5 seconds, the maximum height will be 3 meters. This notation is called a coordinate and is a more effective way of writing down what you read from a graph. We always start with the value that we read from the horizontal axis, which is our 2.5, and then we read the value from the vertical axis, our maximum height of 3. For the second graph, Jana's maximum bank balance is at 26 days, and that will be exactly 4,000 Rand. So the maximum point is 26 and 4,000. Then for both these graphs, we can also identify minimum points. For the soccer ball graph, we have 2 minimum points, at the beginning of the graph and again at the end of the graph, where the ball is on the ground. So here the minimum points will be at a time of 0 along with a height of 0, and then again at a time of 5 seconds with a height of 0. For the graph of Jana's bank balance, there's only one minimum point, and that minimum happened on day 25, and on this day she had 500 Rand in her account. In the next video, we're going to interpret graphs and make some deductions using the graph.